This is your digital electronics lecture over logic implementation. This is corresponds to activity 2.15. Now, one word of caution: the activity doesn't lend itself to um, the form analysis that we've been using. So I've uploaded the Word document, and I expect you to work through the activity. The things that I'm going to need from you are multi-sim printouts of your circuit, and then also I'll need to visibly evaluate a hand circuit that you've built and sign off that it worked. So those are the only two things you're going to turn in. You don't turn in a form, and you don't turn in the Word document with stuff typed into it. So just pay attention to that, and I'll make sure that I make some notes about that on the class website when you download it. But please don't try to submit this as a form. This lecture is going to be fairly quick and really probably only about 5 minutes. We're going to take one more step in marrying these concepts of truth table, schematic, and logic expression. And specifically, we're going to go in this lecture directly from a logic expression to a schematic that we're going to implement in Multisim, and then also build using chips and wires. So sum of products logic expression, uh, we're going to follow a couple steps when we build it. We're going to build the minterms uh, initially on paper with as few gates as possible, and we're going to utilize 2 input, 3 input, and 4 input AND gates and OR gates. Then we're going to have to break them down into 2 input gates that we can use in the lab because that's what we have access to with our chips. So you basically build two schematics for each circuit that you implement. So we start with this example, and we're basically asked to go directly from this logic expression to a schematic, a picture of how this is going to work together. So it's really not very complicated. This logic expression is A naught, B, C naught, D, or B, C, D naught, or A, B naught. So we're basically going to build 4 switches, one for each of the inputs A, B, C, and D. We're going to run those switches through the appropriate gates to end up with the output that we want at the end. Here it is implemented with 4 input and 3 input gates. You'll see that we've taken out the switch part, but there in Multisim there will be a switch at A, B, C, and D. And if you follow the lines, you'll see that first AND gate is indeed A naught B, C naught D. We just attached the appropriate input lines to the gates. This schematic will fully implement the circuit expressed in this logic expression. Now, like I mentioned before in class, we only have 2 input OR gates and 2 and 3 input AND gates, and really we should just use the 2 input AND gates. So we can redesign the circuit, and where we did have like a 4 input AND in kind of the top position, we'll have to re-implement it with 3 2 input ANDs. So hopefully you see how this works. We're still connecting the same things, we're just having to run them through two input gates and then AND the outputs together as opposed to just running them through one 4 input AND. So this is the schematic that you would build in Multisim, and also the schematic that you would build physically and have me sign off on once you get it working correctly. Now there's really not much difference with the product of some logic circuit. Based on the way that the logic expression is given to us, we're going to be using OR gates first, and then we're going to AND the outputs together, as opposed to the last example where we used AND gates first and then put those through OR gates. So here's a product of sums logic expression. You'll notice it looks different, but it's basically the same idea. We're just ANDing together things that we have ORed previously. So here's the first step implementation where we're using 4 and 3 input OR gates and AND gates. And if you follow the lines, you should be able to match up which gate goes with which part of the logic expression. Just like before, we're going to need to re-implement this with 2 input gates. And notice at the end they've used in this presentation a 3 input AND gate. We're going to use 2 input AND gates to implement that same thing. Again, this is the circuit that you would build in Multisim, or the type of circuit that you would build in Multisim, and then also physically wire.